Hey guys, we're going to go over the review for our test tomorrow. Okay, we did this in class, but I just figured in case you weren't here or I don't know, maybe just had some extra questions. So problem number 1 says describe the end behavior of the graph of the polynomial function using infinity notation. Okay, so infinity notation is just always as x approaches negative infinity, and then it just simply wants you to say, what is y doing? In other words, what is f of x approaching? Okay, approaches what? And then as x approaches positive infinity, what is y doing again? That's just what it wants you to say. F of x approaches what? Okay, and so what we do is we just simply look at two things. We look at the degree of the polynomial, and we look at if it's negative or positive overall. So when I look at number 1, I see that my highest power of x is 11. So that means it's an odd degree. So since it's odd, it should look like that. Okay, down then up. Stuff can be going on in the middle, but the ends are going down and the ends are going up. All right, but since it's negative, it's not going to be down then up. It's going to be up then down. If it was positive, it would be down then up. But since it's negative, it's going to be up then down. So, as x goes to the left, alright, so that means it's going up, y is going up, so we say infinity. And then this one we would say negative infinity. Okay, that's how you do that problem. Let's look at number 2. I'm going to keep this same template for doing 2, 3, and 4. Okay, so number 2, look for the highest power of x. That's a power of 4. Okay, so it's even. Then it's negative right here, the negative x to the 4th. Since the highest power of x, this guy, is negative, since the term that had the highest x with the highest power, okay, is negative, that means we consider the polynomial overall to be negative. Okay, so then that means since it's even, it should be going up and up, but since it's negative, it's going to be going down and down. So it'll just be negative infinity and negative infinity. Okay. Problem number 3. Highest power is 3. It's positive, so that's down up. So down would be negative infinity, and then up, that would be positive infinity. Okay. Number 4, the highest power is 2. If you look at number 4, you see the highest power is 2, and it's positive, so it's even, positive, so it's up, up. Great. That's 1 through 4. Okay, problem number 5. Whoop. Problem number 5 says, which point ABC has a multiplicity of 1? You should remember that to have a multiplicity of 1, you look like a line when you're crossing the x-axis. A is the only one that looks like a line when crossing the x-axis. So A. Which point ABC has a multiplicity of 2? Okay, so that means you should look like a parabola when crossing the x-axis. B looks like a parabola when crossing the x-axis. C, oh, I take that one away. Which point has a multiplicity of 3? Remember, to look like multiplicity of 3s, squiggle through the x-axis, okay? And so C is the one that does that. Alright, so that's 5, 6, 7. Let's look at problem number 8. Problem number 8. Identify the zeros from the factors of each polynomial, and then also identify the multiplicities, okay, of each zero if it is greater than 1. So, when we look at problem 8, the way you find zeros is just by setting each piece equal to 0. Okay? So we're just going to say x equals 0. Then we're going to say x plus 2 equals 0. Oops. And then we're going to say x minus 3 equals 0. Okay? So, the first one's already solved for us. That's easy. This next one, we just subtract 2. So we get x equals negative 2. And then on this last one, x minus 3 equals 0, we just add 3, so we get x equals 3. And now we need to just state the multiplicities. When we got x cubed, the x equals 0, 0 came from x cubed, so it has a multiplicity of 3. So I'm just going to put m, means multiplicity, is 3. Alright, the negative 2, 0 came from x plus 2, which has a power of 1, so it just has a multiplicity of 1. And the 0 of 3 came from x minus 3, which was squared, so that means it has a multiplicity of 2. Alright? So I encourage you to pause this video right now and try doing number 9 on your own. Alright? So hopefully you're just unpausing the video, and what you did to do number 9 is you just set each piece equal to 0. Okay, so you said x minus 4 equals 0, you said x plus 3 equals 0, and then you said 2x minus 1 equals 0. Okay, and hopefully you're like, oh, this is easy. X is equal to 4, x is equal to negative 3, and then on this last one, you add 1 divided by 2, so you got x equals 1/2. Okay, and they all have multiplicities of 1 because they all came from powers of 1. Okay, so that would be the answer for number 9. Okay, let's move on. Problem number 10. Problem number 10 just says, list the possible zeros of each polynomial. Okay, possible zeros just comes from this P over Q idea. Okay, so then what you have to know is you have to know what P is, what Q is. P is always the factors of the constant. Okay, so when you look at the polynomial we give you, the constant number is a negative 10. So P is the factors of a negative 10, would just be plus or minus 1, plus or minus 2, plus or minus 5, and then plus or minus 10. Alright, that would be all of the P's. Q is the factors of the leading coefficient. The leading coefficient is simply the number multiplying to the x that has the highest power. So when you look at this, x cubed, that's your x with the highest power. So what is the number multiplying to x cubed? 2. So then Q is just simply the factors of 2, which is plus or minus 1, and then plus or minus 2. So P over Q is just simply all the P's divided by all the Q's. So you're going to do 1 over 1, which is just 1. All right, I'm just going to put plus or minus 1, plus or minus at the very beginning, but it's going to go across all of these. I'm just tired of writing. So plus or minus 1, 1 over 2, so that'd be plus or minus 1/2. All right, 2 over 1, so that'd be plus or minus 2. Now, 2 over 2 is 1, so I don't need to write that again. I already have plus or minus 1, okay? 5 over 1, that's just 5, so plus or minus 5. All right, 5 over 2, so that's just plus or minus 5/2. 10 over 1, so that's just plus or minus 10. And then 10 over 2 would be plus or minus 5, which I already have, so I don't need to write it again. So those are all your possible zeros. I should have written them right here because that's your answer box, but these are all the possible answers. All right, let's do number 11. All right, remember it's P over Q. So P for this problem is 12 because that's my constant. Factors of 12 are 1, 2, 3, 4, 6, and 12. And all of these have plus or minus in front of all of them. All right, Q is 1 because that's the number multiplying to x cubed. So that would just be plus or minus 1. So if you do all the factors of P divided by all the factors of Q, you're going to get plus or minus, and it's going to go to all of them, so I'm just going to open parentheses, 1, 2, 3, 4, 6, and 12. Because 1 over 1 is 1, 2 over 1 is 2, so forth and so forth. So there you go, that's problem 11. Okay, now we're getting to the real doozies of the problems, 12 through 16. Okay, on number 12, I'm going to work it out according to the rational zero theorem. But on the rest, I'm going to show you a shortcut, okay? So, it says find the actual zeros and factors of each polynomial. All right, so we're going to use what's called the rational zero theorem to do that, okay? We should have 3 zeros total, okay? So, we're going to do P over Q to get our possible zeros. So to do P over Q, you first need to know what P is and what Q is. P is negative 4, Q is 1. So all the factors of 4 divided by all the factors of 1, so that's just going to end up being plus or minus 1, plus or minus 2, and plus or minus 4. Awesome possum sauce. Now I need to actually start picking numbers to check against these. Okay, so let's try 2. So I'm going to synthetically divide by 2. All right, so I put 1 for x cubed, 3 for x squared. There are no x's, so you need to put a 0 there because there is no x, and then negative 4. Carry down, multiply, carry down, multiply. All right, then 0 plus 10 is 10. Multiply again, and that's not going to give me 0. Okay, that's fine. So that didn't work. Not a big deal. So instead of 2, I'm going to try negative 2. Carry down, multiply, add. 3 plus negative 2 is 1. Negative 2 times 0 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is 4. Negative 4 plus 4 is 0. Great, so I know negative 2 is one of my zeros. So I'm running out of space. I'm just going to put my zeros over here. Alright, but negative 2 is one of my zeros. So negative 2 is one of them. Now what I have to do is check negative 2 against the new polynomial to see if negative 2 is another possible 0. So 1, 1, negative 2. Carry down my 1. Negative 2 times 1 is negative 2. 1 plus negative 2 is negative 1. Negative 2 times negative 1 is 2. Negative 2 plus 2 is 0. Awesome, so negative 2 worked twice. Okay, now I only have two numbers, 1 and negative 1. So now this guy is easy to just simply say 1x minus 1. So that is the polynomial that I can get from that. And then I can just set that equals 0, and I get that x equals 1. So then my third 0 is 1. So we found the actual zeros, and then it also asks us to find the factors of each polynomial. Okay, well, to find the factors of each polynomial, what you do is you work backwards from your zeros. If you have a 0 and negative 2, you know that came from a factor of x plus 2. Now, I have another 0 and negative 2, so since I have two of these, it would be x plus 2 squared. And then I have a 0 of 1. You know that came from x minus 1. So you know your other factor is just x minus 1. And there you go. There's your zeros, and there's your factors. That's how you use the rational zero theorem to solve if all your zeros are rational numbers. Okay? Now let's look at problem 13. Now we're going to cheat, and we're going to speed ourselves up by, instead of using the rational zero theorem, we're going to use the calculator. Okay, now in order to use the calculator, it's important you remember two things. It's important that you remember what a zero is. A zero is where you're crossing the x-axis, okay, also known as an x-intercept. The second thing that's remembered about a zero is that when you cross the x-axis, y is 0. So what I'm really looking for is, on a graph, I'm looking for where I cross the x-axis, or I'm looking for where y is 0. They mean the same thing. Okay? So, x cubed minus x squared minus 8x plus 12. Okay? So I hit graph. Okay, now, couple things. One, what was the power over here? 3, right? So you're looking for 3 zeros total. However, look at the shape the graph made when I hit this 0. It made a parabolic shape. That means it has a multiplicity of 2. So that means 2 of your zeros are actually happening right here, and 1 of your zeros is happening right here. Okay? So then, I can just say, okay, what is the 0 happening right here? Well, let's figure out what that x value is. So I can hit second trace, go to 0. It says left bound. So I can just move my cursor. As long as I'm on the left side of that 0, which I am, I'm good. So I press enter. Now I just need to get myself to the right side of that 0. Okay, I'm on the right side, so I press enter. Guess, so I press enter again. It's thinking. Hey, 1.9999988, that's just the answer is 2. So we know that I have 2 of my zeros happening at 2. Okay, so 2, 2. And then my other 0 seems to be happening at what looks to be negative 3. Well, rather than hitting second trace and going down to, sorry, I didn't hit it right, second trace, and going down to 0 and doing all that, what you could also do is hit second table and just go see if when x was negative 3, it gave us a 0. It did. So then I know my next 0 is negative 3. Now, the reason I showed you second trace first is because look at these x values when you look at the table. They're all whole numbers. So therefore, if one of my x values was negative, it wouldn't have, if one of my x values was a fraction, I would not see it here on the table. Okay, so in other words, if an x value, a fractional x value, giving me a y value of 0, I wouldn't see it here. So I'd miss one of my zeros. That's why I showed you guys also how to do the second trace 0 function. So that way you could use that if you're not finding one of your zeros. Okay? So, what are the factors if these are my zeros? Well, the factors are simply, alright, so you have 2 2's, so that's just going to be x minus 2 squared, and then negative 3 comes from x plus 3. Okay? Next question. Problem 14. To going to do it the same way. I'm going to let the calculator do all the thinking for me. Go to y equals, click clear, x raised to the 4th. And I'm going to let the calculator do the rest of the thinking for me on all of these, okay? Now, if you wanted me to see it do it the algebraic way, feel free to shoot me a remind or an email saying, hey, can you show me the algebra way for this specific problem? I have no problem going over that with you and even like sending you a picture over email or something of me having worked it out. Okay? So, oh, I almost forgot to put a plus sign here. I'm going to hit graph. And I'm going to look, oh, 1, 2, 3, 4. 4. So I know I should have 4 zeros. These all look to be whole numbers, so I'm just going to see if I can't use the table real fast, okay? Rather than actually have to go through the 0 function. And 1, 2, 3, 4, so -3, 0, 1, and 2. Those are my answers. So my zeros are wherever y was 0, the x values, so -3, 0, 1, and 2. So then the factors from this, the factors I get from this guy are x, x plus 3, x minus 1, and x minus 2. Okay. Alright, so problem 15 now. Okay. Problem 15 is x raised to the 5th minus 5x, whoops, minus 5x raised to the 3rd plus 4x. I'm going to hit graph. And I see that I get my 5 zeros here, 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 since they all look like lines, and I can count 1, 2, 3, 4, 5. And I'm going to see if the table has them. I'm going to see if they're all whole numbers. 1, 2, 3, 4, 5. Wow, that was nice. -2, -1, 0, 1, 2. Okay, so my zeros are -2, -1, 0, 1, 2. Okay, the factors I get from this, well, from 0 you get a factor of x. From -2 you get a factor of x plus 2. From a 0, -1 you get a factor of x plus 1. From a 0 of 1 you get a factor of x minus 1. From a 0 of 2 you get a factor of x minus 2. Bam, there are your factors. Okay, last but not least, problem 16. And honestly, guys, try to do this problem right now without me, because by now you should be able to do this lickety-split. By the way, you probably don't have a graphing calculator at home. Feel free to use Desmos. Okay, feel free to use Desmos, DESMOS.com. Alright, it's a really nice graphing calculator, okay? While you're working on this review, you won't be able to use it on the test, but I will provide calculators. Alright, but feel free to use Desmos for right now. Okay, so 2x squared minus 4x. And in fact, I'm not, no, never mind. Hit graph. Okay, so first off, I know I should have 3 total, and you should notice that you have 2 happening right here because this looks like a parabola, right? So you know, since it looks like a parabola, you have a multiplicity of 2 happening. So once again, I'm going to cheat and see if I can't just get them all real fast. 2 zeros, but I know 2 of them are happening right here at -2. So the factors from that are x plus 2 and x minus 2, but x plus 2 is being squared because it looks like a parabola at -2. Okay guys, hope this video was somewhat helpful. Please let me know if you have any questions. Feel free to send me an email. Feel free to send me a remind. Remember, we're in the computer lab J104 for tomorrow, which is the 29th of March, the year 2018. Alright, thank you.